So let's start the story 50 years ago. 50 years ago, Pioneer 10 was launched from Cape Canaveral on its mission to become the first spacecraft to fly past Jupiter, which it did a year later in November 73. After passing Jupiter, it continued its journey, and it's become only first of only 5 spacecraft to pass beyond the orbit of Neptune, and it's now drifting out through interstellar space, getting further and further from the sun. The spacecraft could last for millions, perhaps even billions of years, and could in theory be picked up by an alien civilization. So just in case this should ever happen, Pioneer 10 carries this plaque shown here, and this would tell intelligent beings from another planet where the spacecraft have come from and give them some sort of basic humanity, basic information about humanity. So what I'm going to do is just go through a little bit about this plaque. It was designed by Carl Sagan, who many of you will know for his Cosmos TV series in the 80s, sadly no longer with us. And it shows 4 relatively simple things. At the top of the plaque, this represents a hydrogen atom, hydrogen being the most abundant element in the universe. And on the right here, you've got a figure of a man and a woman. And you can see the man has got his hand up in a gesture of friendship. Although, of course, there's no way of knowing whether an alien race would correctly interpret that as being friendship. No, somebody's rustling a bit. Do you mind going on mute? Thank you. Yes, so the man's got his hand up in a gesture of friendship, but of course, there's no way of knowing whether an alien race would interpret that way. And these figures have caused some controversy. Some people have objected to the lack of clothing, saying they're pornographic. But to me, it makes more sense to have them naked, because having clothes, you miss bits of the anatomy and it ties it into a particular culture. But others, more significantly, feel that the man and woman are both Caucasian, so it's not representative of mankind. And why has the man got his hand raised and not the woman? Behind the figures of the man and woman, there's the spacecraft, and it's all drawn to the same scale. So the idea is an alien race could figure out how large we are. At the bottom, you've got the sun and the 9 planets. So this shows, the 3rd planet shows where the spacecraft has come from. That's the Earth. And the 5th planet is where it was going to, which was Jupiter. Now, it's a little bit out of date because, of course, we don't have 9 planets now. Pluto was demoted to a dwarf planet in 2006. But probably one of the most significant parts of it is this diagram here. It's a funny diagram. It's got 15 lines coming out of a central point. And the central point represents the sun, and the right-hand line represents the center of the galaxy. And the idea of this pulsar map is to show basically where the spacecraft have come from. And that's, so if we're showing a little bit more detail, you've got the fact the line segment closest to the sun here shows basically the distance of the pulsar from the sun, right? So let's have a look here. Yeah, so basically what you've got here, a line segment, is this is the distance from the center of the sun. This line segment here, second one, is the pulsar's distance or below the galactic plane. And then you've got this sort of series of noughts and ones. And what that is the period of the pulsar. Now, obviously, it's not in seconds. It's in units of a small fraction of a billionth of a second, which is effectively the frequency of the hydrogen line flipped over. So hydrogen line is about 1.5 billion cycles per second. That is 1.5 billionth of a second. So that's the fundamental time unit which an alien race should hopefully understand. And the thing about pulsars is their period is fixed, the location is fixed, and the idea is that if an alien race were to find this plaque, they could use these pulsars as beacons to pinpoint from where the spacecraft has come from. In fact, that's not strictly true because the period of pulsars isn't fixed. It's actually slowing down slightly. But hold that thought for a minute. So the next spacecraft to be launched was Pioneer 11. And that was launched a year later. And it went past Saturn, which it did in 79, as well as Jupiter. And it carried an identical plaque to Pioneer 10. So moving on a little bit further in time, we'll go to the Voyagers. And these were two spacecraft. First one, Voyager 1, was launched in 1977 and went past Jupiter and Saturn. The next spacecraft, Voyager 2, went past Jupiter, Saturn, Uranus, and Neptune. And this is where they are now. You can see the trajectory. And this shows the trajectory after passing the final targets. They were deflected out of the solar system away from the ecliptic. Now, each Voyager, you can see, had one of these on, this little golden thing here, and this is a golden record attached to it. And this golden record, if I zoom in, had a sleeve which had instructions on how to play the record and the record itself. And you might recognize this Drake's pulsar map and the hydrogen atoms, and that was repeated from the Pioneer plaque. But because of the controversy caused by the figures, they weren't included. But these instructions here are instructions on how to play the golden record. And I've just put them there. And the idea is that if you play it at a particular speed with the stylus, which is attached to it, then you will get a mixture of pictures and sounds. Right. The first picture being a circle. So these instructions here, the words weren't included, but these diagrams were included, should hopefully give an alien civilization the ability to play the golden record. So on the golden record, what we have is greetings in 55 different languages, natural sounds, some music, images, variety of objects, planets, human anatomy, landmarks, interesting places such as the Golden Gate Bridge, and a message from Jimmy Carter. And because it was made in 77, of course, as I've just said, all this was in analog format. So if we look at now the music, it's quite an eclectic collection, because how the hell do you represent the music from Earth on a single record? Well, obviously you can't. So this just showed, there were 27 tracks in total, and there's a complete mixture of sort of classical music, percussion music from Senegal, Pygmy Girls' initiation song, men's house song from New Guinea, Japanese music, completely bagpipes from Azerbaijan, completely eclectic mix intending to sample the world's music. And this is Jimmy Carter's message. And I just love this. You know, I'll just put it up for a minute or so you can see it. And the sort of the optimism in that message is amazing. So the final spacecraft to leave the solar system was New Horizons, which was launched in 2006. It was launched the same year it was launched. Pluto was actually downgraded 8 months after launch. After it passed Pluto, it went past an object called 486958 Arakoth, which is probably better known as Ultima Thule. And now it's hunting for Kuiper Belt objects. So these are objects well beyond the orbit of Neptune. There haven't been any identified that can easily get to, bearing in mind its limited fuel on board. So it can't steer too far from its trajectory, but hopefully NASA will uncover something that it can do a close flyby to with its limited resources of fuel. Now, New Horizons had 9 objects aboard, reason for 9, going to the 9th planet, Pluto. And they are ashes of Clyde Tombaugh, who discovered Pluto, CD of 434,000 people who submitted their details to the project. Now, sadly, I wasn't aware of this at the time. And if I had done, I'd love to have my name aboard a spacecraft that was going to leave the solar system. But sadly, I guess it wasn't too well publicized at the time. And I didn't get my name there. I don't know if anybody else in this group did or was aware of it. But that would be an amazing thing to have done. CD with the pictures of some of the staff who worked on the spacecraft. He had a quarter, 25 cents from Maryland. The significance of Maryland is where the spacecraft was largely built. And 25-cent coin from Florida, which was where the spacecraft was launched. And a small piece of Spaceship One, which you may recall, it was the first privately funded spacecraft to fly into space. There were 2 United States flags. Now, I'm not sure why there were 2, but there were 2 United States flags aboard. And finally, a 1991 postage stamp complaining Pluto not yet explored. That's what it was. So, where are these spacecraft now? Well, this is a trajectory now as they're all moving away from the solar system. And in numbers, that's what they look like. Now you can see the numbers for the Pioneers are estimates. That's because the spacecraft is no longer communicating with NASA. So it's just a guess based on its last trajectory. No data has come back from these spacecraft. But we're still in contact with Voyager 1 and Voyager 2. And Voyager 1 now is 155 AU away from the Earth. So that's more than 5 times the orbit of Neptune. But even so, to put it in perspective, that's only 0.1% of the distance to Proxima Centauri, the nearest star. So finally, to wrap up this first part of the talk, will these spacecraft ever be found? Well, I think it's exceedingly unlikely. I mean, to be honest, that's to say it's a bit of an understatement is putting it too mildly, because the spacecraft are small and the power sources will die within the next few decades. So they can't transmit a signal which will enable them to pick up. So if we look, again, saying it's a needle in a haystack is a bit of an understatement. And also, the other thing is, are there any civilizations around to uncover them? If you're like me and you believe that civilization in our galaxy is extremely rare, then there won't be anybody around to find them anyway. But I suppose it's just about within the realms of possibility that in our far distant future, long after the Voyagers, Pioneers and New Horizons have been forgotten, perhaps mankind itself might leave Earth, colonize planets around other stars. And we're talking about millions of years in the future here. And maybe some of our descendants would uncover one of these spacecraft by accident, stumble into them, in which case it's fascinating to think what they'd make of them. And just to finish on a lighter note, the Pioneer plaques have appeared in fiction quite a bit, and perhaps not surprisingly, there's many Star Trek episodes they've appeared in, 5 to my knowledge. But perhaps the funniest one is they actually appeared in an episode of The Simpsons, briefly, where an alien was looking at the Pioneer plaque uncovered. But if you look carefully, you'll see that he's actually looking at it upside down. So I'm going to stop now and stop sharing this part with us. Are there any questions?
Would anyone like to shout out any questions to Steve? There's a couple of questions in the comments in the chat. There's one from Elaine. Do you believe there's any life in the universe? Although I think that's from her son.
So age 11. Well, it's an open question. I mean, it's something which I believe. If I say within the Milky Way galaxy, I'm of the opinion that life is extremely rare. It's inclined towards the rare earth hypothesis, where it's a sequence of extremely unlikely events which have occurred, which have meant that life has evolved on Earth. So we're alone in the galaxy. The universe as itself, I mean, depends whether you mean the observable universe, which might be part of a larger universe as a whole. I think there probably is intelligent life in the universe, but it might be so rare that we've, you know, we may never come across it. But again, that that's my view, and you know, I wouldn't pretend to be an expert on this, and there are many astronomers who have a different view. So probably the most famous being Frank Drake, who's famous for his Drake equation, or Seth Shostak, who runs the SETI Institute.
Could I ask? I was intrigued by your table there to say that we're not in contact with the first two of the spaceships, and the fact they've gone 1 billion kilometres. At what point do you lose contact? You know, those Voyager things, they've gone miles. I mean, well, how far can you actually transmit and talk to these spaceships? It seems incredible that you can contact a spaceship, you know, the size of a dustbin, a billion kilometers away.
Yeah, well, let's put this. Shall I share I'll share my screen again, and we can all see this table. That's it. Right. Can you see that table?
Yes.
Yeah. I mean, it is interesting. I mean, you know, we don't know why we've lost contact with the pioneers, and it might be that the power source has died, but it might also be that the spacecraft has gone out of alignment, so the transmitter is no longer pointing at Earth, is another possibility. But yeah, I mean, it's pretty impressive that particular Voyager 1, which is 5 times the distance from Neptune, 23 billion kilometers, you know, we're still able to pick up a signal from it. I find absolutely amazing. And I think they're looking at least another 5 years before perhaps we lose contact with this. Yeah, it's.
When you say it's lost alignment, the Earth's travelling around the sun, isn't it? So there must be some technology on there that's moving the dishes there. That's tracking
no, because it sort of sprays out over. It sprays out over. It'll spray out over such a large area. It will be picked up. You know, the angular distance between the Earth and the sun is quite small. So it will, I believe it's not constantly aligning with the Earth. again, but that's a good question. Actually, I'll double check on that.
Steve, do you know, are there any other objects that are planned to leave the solar system in the near future, or are there any other objects on their way to leaving the solar system?
No, I'm not aware of any. I think the Voyager, well, we've had the Pioneers, the Voyagers, New Horizons. So no, there's no planned spacecraft to the outer planets, Uranus and Neptune. There's of course JUICE going to the moons of Jupiter, which is being launched this year. But there are various proposals on the table, but nothing in the pipeline. Yeah, I mean, I guess it all comes down to funding, really, because at the moment Mars is the big one that people are going for, because people and things like the moons of Jupiter to a lesser degree, and of course Enceladus around Saturn. So sending something to the outer planets is probably lower down the list.
And the probes that are going to the moons of Jupiter and Saturn will get captured in orbit there and stay there.
JUICE will end up orbiting Ganymede at the end of its life, and then when its fuel runs out, it will just orbit Ganymede forever. Whereas the 5 probes were launched on such trajectories that they were just flypasts, and then it was carry on going into interstellar space.
We have a talk. We have a repeat. We had Paul Money spoke to us a while ago about Voyager 1, and he's coming back to talk to us about Voyager 2 later this year.
Right. Okay.
So would it be fair to say that the plaques, the symbols, the record were absolutely incidental to the missions, and they were?
Oh, absolutely, yes. Yeah, I mean, they were just tagged on. You could cynically say as a bit of a gimmick, really, a bit of a PR stunt. I mean, it wasn't. I think if you were to ask the project team, I don't think anybody seriously expects these spacecraft to be uncovered, because the chances are so small. But it was thought, it'd be a nice thing to do, because in theory that could happen, although it's exceedingly unlikely is a bit of an understatement. But,
and I think you said you thought these things would last for millions or billions of years.
Yeah. But well, again, potentially you think about what's going to actually, because if they're floating through interstellar space,
there's no road. There's no road salt.
No, there's no road salt. Unless we don't know where they're going to end up fully, because once they get well beyond the sun's gravity, they'll be deflected by stars, and if they don't pass through a thick dust cloud or something, what's going to certainly millions of years.
Steve, just a question. I'm sorry, I don't know what this is. What are the power sources on these ships? Is it solar panels and batteries, or?
No. They're nuclear powered. So, yeah.
Really?
Yeah. Nearly all the spacecraft, which certainly the earlier spacecraft that left the solar system, are powered by. They have isotopes, and I think one I'm not sure there's that, but one is plutonium-238, and it decays over a period of about 50 years. And
right, okay.
Yeah, and it's the power source. So the half-life's about 50 years. So eventually, the amount of power available drops, but you wouldn't get any energy from solar panels. So
they don't carry a health warning or anything like that if anybody did find them. That's what I was driving at.
Well, it's quite interesting.
Got to be a bit careful with this, guys. All right.
Yeah, because I was thinking about it.
Launched on us.
No, Jason, that's a really interesting point, because if you were to launch something like that today, putting a big lump of plutonium on a rocket, and in theory that could then sort of crash, that could then explode going into space and scatter. I think there'd be more people more worried about it than perhaps they were in the 70s.
Yeah. I'm astonished at that, Steve. I had no idea they were nuclear powered, essentially. Yeah.
Yeah, it's not a nuclear reactor. It's not working by fission, but it's a radioisotope which decays over decades, and that is your constant heat source. Yeah.
And
So
is that a bucketful, a baked bean can full, a teaspoonful?
It can generate a few kilowatts, so it's again, I'll double check on this. I think it's like a tennis ball size amount, but I may not be right about that. So.
But really, the only reason why they were powered like that was because they were traveling such a long distance.
Yeah, I mean, you know, if you obviously, you know, you think about the inverse square law. You know, when you get to Jupiter, which is 5 times further away from the sun than the Earth, you've got a 25th of the power. By the time you get to Neptune, 30 times away, you've only got a 900th of the solar power available. So you'd have to have absolutely enormous solar panels, and then even then you get beyond Neptune, then it just stopped working. And the intention of these spacecraft, the Voyagers, was always the primary mission was to visit the outer planets, but the interstellar mission they're now on was always tacked on as the thing to come afterwards.
Right. Yeah. Thank you, Steve. Yeah.
Right. Okay. Well, I'll go on to the next presentation then, which is, so just take. This is the METI one. Right. So. That's the wrong one. Messages. Right, can people see that?
Messages from Earth we can see, Steve.
Yeah, and is that talking about 3 strands to this talk? Can you see that?
Absolutely, yes.
Right, brilliant. Okay, right. So this is a follow-on talk. It's about sending messages from Earth in the hope that we might be picked up by an alien civilization. So there's 3 strands. There's making ourselves understood, the whole problem, example of some messages, and question, should we be doing this? And which has been asked by many people. So this activity is sometimes called METI. And what is METI? METI stands for Messaging Extraterrestrial Intelligence. And it's sending messages to stars which have planets on which intelligent life may have evolved. And it's sometimes called active SETI, an activity which has been pursued on and off for the last 50 years. So. Now, one of the challenges, obvious challenge, is if you're transmitting a message to an alien civilization, is writing it in such a way that it could be understood by someone receiving it. Because the recipients would have no knowledge of Earth, any of its culture, and in all likelihood would act very differently from human beings. And the difficulties are illustrated by hundreds of stone tablets found on the Greek island of Crete. And these are written in a language called Linear A, roughly 4,500 years ago. So it's around about the time of the ancient Egyptians. And no one has managed to decipher these tablets because they have letters which appear in no other known language. What you need is something like the Rosetta Stone, which is a large stone found in 1799. I've seen it a couple of times. It's in the British Museum, and it's inscribed with the same decree issued at Memphis in Egypt in 3 different languages. The top is ancient Egyptian using hieroglyphics. The second is ancient Egyptian using a symbol alphabet, and at the bottom is ancient Greek. So by using this to decipher the hieroglyphic script, it opened a window into ancient Egyptian history, which we didn't have before. Now, what I'm going to do now is talk about a few examples of messages and how we've sort of tried to get around this problem. And probably the most famous message is the Arecibo message. And it's designed by Frank Drake in 1974. And he's the guy on the right. And he's shown with Carl Sagan, the guy on the left, who's also involved. And even 50 years later, this is probably the most famous example of a message which aliens could potentially at least understand. So what Drake decided to do is to convey some basic information about humanity by sending a simple picture which somebody could, receiving the message, could construct. And the message was transmitted from the Arecibo telescope at a wavelength of 12.6 centimeters. And it consisted of a sequence of 1,769 zeros and ones. And what's special about that number is it's called co-prime. It only has two numbers which divide into it like giving remainder, and those are 23 and 73. So the idea is if an alien civilization received this message, then perhaps they would naturally write it out in a 23 by 73, or perhaps a 73 by 23 grid. And if you do this, and then you do it like this, where you have the ones are translated into graphics character squares, and there's the zeros into black squares, then you sort of see a picture. In fact, it looks a lot better than that, which is just the zeros and ones. So we go from that to that, right? And we've got a sort of picture. But normally on websites and books, you'll see it done like this. And obviously the message can't have any color, but this is done to sort of highlight the different components in this message. And that's what I'm going to talk a little bit about it next. So I'll go through these components. The top bit, the white blocks, are the numbers 1 to 10, and I'll talk about these in a little bit. Now, below those, you have the numbers 1, 6, 7, 8, and 15, and these are the atomic numbers of the elements hydrogen, carbon, nitrogen, oxygen, and phosphorus. And these make up, these are used in all DNA. And DNA obviously holds the genetic information of all living organisms found on Earth, apart from viruses. And if it's a big if, the civilization reading this message has the genetic information held in a similar way, then perhaps this might make sense to them. So below that, you've got the green blocks, and these show the chemical formula, numbers of atoms of carbon, hydrogen, nitrogen, oxygen, and phosphorus in each of the basic building blocks of DNA. So the first one, deoxyribose, has 7 H's, 5 carbons, no nitrogen, 1 oxygen, and no phosphorus. Below that, you've got the blue, which is the double helix, which is the basic structure of DNA. And superimposed upon this are the white blocks, which is a massive number, approximately 4.3 billion, which was believed to be the number of basic building blocks in human DNA. Now we know that to be slightly wrong now. The actual number is a bit less than that, but at the time we believed it was 4.3 billion. The red figure is a graphic of a human, and to its left in white is the number, which is the average height of a human. Now, obviously, we can't specify that in centimeters, feet, and inches or anything. So it's multiples of 12.6, which is the wavelength the message was transmitted on. And it's 14, because 14 times 12.6 is 176.4, which is roughly the height of the human, average human. Now, to the right is the human population at the time the message was transmitted. And below that, we have a plan of the sun and its 9 planets. So you've got the big one is the sun, Mercury, Venus, Earth, Mars, Jupiter and Saturn, the giant planets, Uranus, Neptune, the larger planets. And then of course, we've got Pluto, which of course is no longer a planet. And you see the Earth is raised because that's where the spacecraft come to. And below that, you've got its, you've got the Arecibo telescope and a number which is its diameter in multiples of 12.6 centimeters. So you recall at the start I said reading the numbers. This is how we read the numbers. So it's so I've just repeated the first row of the message, and it's read by a combination of rows and columns. So if you look at number 1, you've got a value just in third row, column 1. Second row, column 1 for 2. That's 3. That's 4, 5, 6, 7. And then when you go to 8, you put a value in column 2. Right, and then back to column 1. So that's the way you read the numbers. So the message was transmitted on the 16th of November 1974, nearly 50 years ago, and it took 3 minutes to send at a low rate, only 10 bits per second. And it was aimed at the center of M13, which is a large globular cluster, 25,000 light years away. But of course, the target will have moved by the year 27,000. So M13 will no longer be there when the message gets there. But of course, anybody could intercept it on its way. And it was retransmitted again in 1999 and 2003 as part of a cosmic call. Now, cosmic call was a message which was sent to sun-like stars. So it wasn't a god, it was 7 or 8 sun-like stars. And it also had quite complex messages which tried to explain mathematics and physics to alien civilizations. If you want to know more, I've put the link there, which is still work. Now, my view is the cosmic call message was far too complicated, but yeah, I mean, they rather than aim it at a globular cluster, it was targeted towards 8 Earth-like planets. And then it was resent again in 2016 as part of a simple response. And I'm going to talk about the simple response a little bit later. Another one is pretty notable, was a message from Earth. It was sent in 2008 towards Gliese 581c, which is an Earth-like planet which orbits the star Gliese 581, about 20 light years away. And it's a digital time capsule containing 501 different messages that were selected through a competition on the Bebo social network site. Now, many of you will be aware Bebo no longer exists. And it contains a variety of information, such as details about the contributor's own life and ambitions and images of famous landmarks and famous people. But I think if an alien civilization and Gliese 581 were receiving this, they'd find it impossible to decipher. For one of the things, most of the messages are in English. Another one, and I'll come on to this. This had quite a lot of publicity back in 2016, and this was compiled by a number of academic institutions were involved in this. And the idea was the public were asked to answer this question: how will our present environmental interactions shape the future? And they had a total of over 4,000 submissions, of which 3,800 were deemed to answer the question. And these messages were submitted by individuals from all over the world, 146 countries, 16 different languages. And these, this was, if you like, a time capsule that was sent across, providing information about the planet, our stewardship, discussion on ecological issues. And it was transmitted towards Polaris, of all places. And, Seth Shostak made an interesting point about this. Yes, it was perhaps in English. Yes, it might be difficult to decipher, but hey, what we're saying is we're here. We're here. We're clever enough to build a radio transmitter. Now, finally, to come back full circle, a couple of years ago, there were plans for a second Arecibo message, and this was to coincide with the 50th anniversary of the original Arecibo message. And what Arecibo Observatory did is they put the task out to students all over the world, and they're given the task of defining a new Arecibo message. And in November 2020, so a little more than a year ago, the challenge winner was announced, and they then started work on constructing the message, and more information is available there on that website. But sadly, of course, since then the dish collapsed and the project is unfortunately now on hold. Now, this is an interesting question, which I'm going to pose. Should we be doing this at all? And part of this, as questions come around with, there was a group of businessmen who launched a project called Lone Signal. And this was crowdfunded. They started it in 2013 with a target to raise $100 million to buy time on telescopes to send messages out to stars, which they believe have planets on. Unfortunately, the project never really got off the ground and is now defunct. But it did raise that interesting question, because, for instance, you've got the Breakthrough Prize by the Russian billionaire Yuri Milner, and he's talked about spending a lot of money, perhaps to buy time on telescopes to send messages out to the potentially to stars who could have planets with intelligent civilization. So it raised the question, should we be doing this? And I'm just going to, let me stop sharing because I've got a little bit of audio to. No, stop. Right, so what I wanted to do.
If aliens visit us, the outcome would be much as when Columbus landed in America, which didn't turn out well for the Native Americans.
So yeah, he raised an interesting point. And in later life, Stephen Hawking became more and more convinced that perhaps it wasn't a good idea that we should be doing this. We shouldn't be advertising our presence. And in 2015, a group, there's quite a wide-ranging group of astronomers, thinkers, people involved in SETI, has put out this statement, basically saying, there's a number of things I'll highlight. Firstly, the decision about whether or not to transmit should be based on a worldwide consensus and not a few rich individuals with access to powerful communications equipment. And extraterrestrial reaction to a message from Earth, we don't know. We know nothing about their intentions and capabilities. And you can't tell if they're going to be benign or hostile. And if anyone were to receive it, if there were an intelligent civilization out there, the chances are, that we're just on the very early stages of having interstellar communication. It's likely that any other civilization will be millions of years more advanced than us. And it's quite interesting to look at the signatures to the left. So you've got people like Elon Musk. You've also got Paul Davis. He's a English physicist, writer, broadcaster. Michael Davis, who's an American philosopher. George Dyson, a science writer. And perhaps closer to home, we've got our own Tim O'Brien, who's a professor of radio astronomy at Jodrell Bank. So quite a wide-ranging group of people, urging us to be cautious. And I think it's a fair point. It shouldn't be just the wishes of a few rich individuals. But to sign off on a more positive note, I'll go back to a letter from Seth Shostak, who's very much, he's very involved in SETI. He's well into his 70s now, but he's still very active in SETI and runs the SETI Institute. Basically, he's saying, we've already been sending TV and radio signals for the last 130 years, and the universe beckons, and we can do better than sort of quake in our boots that there are intelligent civilizations out there to harm us. So on that note, I'll stop talking and I'll say, are there any questions?